Welcome to my video presentation. Starting off with the sequence diagram. The sequence diagram is also known as the event diagram and has a purpose of showing the interaction between the objects in a sequential order. The first sequence diagram is created based on the manage account call use case. And as you can see, the diagram consists of actors, an admin, and an email system depicting the user and the external system. There are also lifelines depicting the objects. For example, the main flow consists of a manage account interface and an auto email interface, which are the boundary classes. The manage account control is the control class, while the member is the entity. The diagram also includes activation bars indicated in blue to indicate that the object is active. The manage account main flow starts with the admin checking the existence of the member record with the member entity using a message denoted in the diagram as a normal arrow, and the system returning existence of the member record using a return message denoted in the diagram as a dotted arrow. On the condition that the member record do not exist in the member's entity, the admin actor will initiate the fifth function, enter account details, and once the new member's record has been created, the system will send an email notification to the member. Next, the alternate flow will be that after the admin initiate the check existence function, the system found an existing records and return the existing record details. The sequence diagram will end with the system sending a self message to itself denoted as a U-shaped arrow. Moving on to the second sequence diagram, this diagram is modeled based on the reserve item call use case. For this main flow, it has four different classes, namely the entity class, reserve and e-library item, the control class, reserve item control, the boundary class, reserve item interface. The sequence diagram will start with the digital library patron searching for their desired item, and on the condition that the library item exists, the system will respond by displaying the information of the library item, to which the library patron can send a reservation request, and the system will respond by initiating the reservation process and updating the book status. Once the book status has been successfully updated and the reservation is successful, the digital library patron can log out of their account. Moving on to the alternate flow for this reserve item, this sequence diagram will start if the library patron found that they reserved the wrong item and would wish to correct or switch the wrong item to the right one. Once the correct item has been found, the library patron can start the switch item function, to which the system will respond by changing the reservation details and updating the book status. This sequence diagram will end with an email notification sent to the user of their changes in their reservation. This alternate flow has two more extra classes, namely the boundary class, an auto email interface, and an actor email system that depicts the external system. Moving on to the VOPC diagram. This is a diagram to show all the participating classes in the sequence diagram. The VOPC diagram consists of the name of the class, the attribute, and the operation. It usually uses visibility markers to show the access right of the class. For example, the plus and a minus sign indicates the visibility to be public and private respectively. For the manage account VOPC, one manage account interface can interact with one manage account control, and one manage account control can create 0 to many members record. This is because it is possible to have 0 or more records. Also, one manage account control can send one auto email. Next, for the reserve item VOPC, one e-library interface can interact with one library control, and one library control can interact with one reservation and send one auto email. However, one e-library control can create 0 or many e-library items. Moving forward to the database schema, the database schema is a visual representation of a database. The PK and FK indicated in the diagram indicates primary and foreign key. The foreign key provides a link between the tables by cross-referencing to the primary key. On the other hand, the primary key is a unique identifier to identify all the table records. For this schema, the members table and the reserve table has a one-to-many relationship. This means that exactly one member can reserve 0 to many reservations. The reserve table and the e-library item table has a many-to-many relationship. In this relationship, a reserve table can have many reserve ID, while one e-library item table can consist of many library item ID. Moving on to the database notation, the members ID in the reserve table will act as foreign key and reference to the primary key members ID in the members table. The reserve library item table includes two data which act both as the primary key and the foreign key. The data in the reserve library item will act as foreign key and reference to the respective PK, namely library item ID from the e-library item table and reserve ID from the reservation table. Thank you for your kind attention. That's all for my presentation.